Start with listing the given quantities. And that's what we have here. Theta prime ball, and we're going to rename that theta 1, just again, instead of writing ball all the time, we'll just write 1, is 53.1 degrees. Theta prime pin, and we'll rename the pin object 2. Its theta is 30 degrees, and P2 prime is 18 kilogram meters per second. I'm not going to worry about negative or positive here because we're going to take advantage of the sketches and figure out which way the velocities and momentums are. And we want to find all the way over here the velocity of the ball, which we will call V1. We're actually going to work this problem backwards in that we're given the after conditions and we need to find the before. So a good place to start is conservation of momentum in the x and y directions, as this is a two-dimensional problem. In the x direction, we have our initial velocities of P1 and P2 will equal the final momenta. Initial momenta, final momenta. P2x, the initial momentum of the pin is 0, so that cancels out right away. So we're left with here's our conservation of momentum in the x direction. The y direction, similar equation, except instead of x we put y. Now what's our initial momentum in the y direction? Well, this ball isn't, the pin isn't moving, and the ball is only moving in the x direction. So these both get replaced by 0. We get P1y prime plus P2y prime equals 0. And we come up with this relationship for the final momenta in the y direction. Now remember, we have to find the velocity of this ball. So all we have to do, and take a couple more slides, is find the initial momentum of this ball through conservation of momentum, then divide it by the mass of the ball, and we're all done. It's still going to take a little while though. We need to find P1x because once we get that, we can divide that by the mass and find the velocity of the bowling ball. And that will be P1 prime x plus P2 prime x. So let's take these quantities over here and resolve them into their x components. First of all, for the pin, which is P2, the hypotenuse of this is 18. It makes a right triangle like this. So when we want to find P1, P2 prime x, it's just 18 times the cosine of 30. And we get P prime 2x is 15.6. We're going to leave the units off here. We'll bring them back at the end because we're doing so much math. Now to find P1 prime 1x up here, we don't have a hypotenuse. All we have is an angle. So what we can do is we can just take this right triangle, and the tangent of the angle 53.1 is equal to the opposite side, which is P prime 1y, divided by the adjacent P prime 1x, and we wind up with P prime 1x is 0.751 P prime 1y. Okay, that's great. We've got this term over here. Now P prime 1x is now expressed in terms of P prime 1y. So our next step is to find that value. In order to find P prime 1y, we go back 2 slides, and you can go ahead and check it. Go back 2 slides where we did conservation of momentum and came up with this. So what do we have here? We have, here's P2, it's 18. Okay, so it's minus 18, and we want to take the sine of this angle here. So in this case, we'll call it negative 30, and then we take negative 18 sine negative 30 equals 9. Now that makes sense to us because we know that P prime 1y is up in the positive direction. So even if we just use 30 here, we would have known to switch it and make sure that we have a positive momentum here for P prime 1y. Now go back to the previous slide where we had P prime 1x was 0.751 times P prime 1y. We carry out the multiplication. Now I can put the number in right there, and you get 6.76. We now know P prime 1x, and we know P prime 2x from the previous page. We substitute the numbers in. Here 6.76 comes here. We found 15.6 on the previous page, and we now know that P1x, which also is the total momentum here, because you have no momentum in the y direction, is 22.4 kilogram meters per second. Told you we'd put the units back in at the end. Now we need to find the velocity of the bowling ball. That's P1 over the mass of the bowling ball. 22.4 comes over here. The mass of the bowling ball is 5 kilograms. And we wind up with the final answer that the initial velocity of the bowling ball was 4.5 meters per second in the positive direction.